It's you open your mouth. Don't you Oh. Hey kids. How's school?
School is good, but chemistry's really hard. Yeah.
What are you guys learning?
Reaction rates.
Oh, maybe we can help tutor you.
I call Dad. I'll call Daddy.
Okay, let's go. Okay, daughter, what's confusing you the most?
I'm lost on the basics. I need to understand the main points of reaction rate.
Well, reaction rates are pretty simple. It's just how fast or slow a reaction occurs.
Oh.
Yeah. There is even an equation for the average rate of reaction.
What's that?
It looks like this.
Oh.
Yeah. And a reaction occurs due to this thing called collision theory, which basically means that the particles collide at the proper speed and orientation in order for a reaction to start.
Oh.
Let's look at an example with your father.
Okay.
It's like when you're baking a cake. You have to beat the eggs to the right consistency for it to mix well with the other ingredients. As you add more ingredients to the mixture, you have to keep the batter at the right consistency.
Alright, that makes sense. My teacher mentioned something about activation energy. What's that?
Well, that's simple. It's just that every reaction needs a startup energy. Once it reaches the activation energy required, an activated complex forms, which is an immediate structure formed in the conversion of reactants to products. Again, with the cake batter, to keep it at the right consistency, you have to turn the mixer on. And it has to be at the right speed in order for the batter to not fly everywhere. Once it gets at the startup energy, the reaction becomes easier to complete and the products are formed. It's like a bump in the road and is represented by this graph.
Alright. Now, is there something that can change how fast a reaction occurs?
Yep. There's 5 key things that can speed up or slow down reactions. Number 1 is temperature. So if I add heat to a reaction, I can speed it up. But
if you take away heat, the reaction will slow down?
exactly. If you try to bake a cake at 500 degrees for 20 minutes, the cake will burn. It's burned. To make sure the cake bakes evenly and well, lowering the temperature to 375 degrees will make it take longer, but it won't look burnt in 20 minutes.
It's perfect!
Number 2 is concentration. This is pretty simple. If you have a higher concentration of popcorn, let's say 5 bags, it takes a longer time to cook it. When you have a lower concentration of popcorn, maybe just 1 bag, it only takes a few seconds to cook. Great! Moving on to number 3, surface area. This goes with number 2. The larger surface area that you have the more the particles can collide with, which causes the reaction to go faster. I doubt you need an example for this.
Nope, I get it.
Okay, last but not least, we have numbers 4 and 5, inhibitors and catalysts. Inhibitors will slow down a reaction. Preservatives are a good example of this. They'll keep your food from rotting. Dad takes out a spoonful of peanut butter, but forgets and leaves it on the counter. A while later, Sabria comes in and eats the peanut butter because the preservatives have kept it safe. Whereas when Dad takes strawberries out and is called to another room,
Dad, I need you.
he forgets them and they don't have the preservatives to keep them healthy. A while later, when Sabria walks into the kitchen, the strawberries have gotten mold on them. Catalysts are the opposite of inhibitors. They speed up a reaction, but aren't changed or used up in the process. They also don't affect how much product you end up with.
Awesome. Thanks, Dad. I get it now.
Alright, so what's troubling you about reaction rates?
Well, I understand all of the basics, but there are a few more complex details that are throwing me off. Can you explain equilibrium?
Okay. Well, equilibrium is a pretty simple concept. In equilibrium, the rate of the primary reaction differs from the rate of the reverse reaction.
In an equilibrium, the foam at the top and the foam at the bottom have to reach an even point for it to be drinkable. As with water in an equilibrium, it doesn't take that long, and it's easier to drink. So, what is dynamic equilibrium?
This is where it's a little more confusing. Dynamic equilibrium is similar to equilibrium except that both the primary and the reverse occur at the same rate. The time it takes to mix the oil and the water is the same amount of time it will take for them to separate again. Oh no. Is it vibrating?
Okay, that makes sense. Now, what is Le Chatelier's principle?
It's a simple concept. If you disturb a reaction, the reaction will shift in order to regain equilibrium.
What?
Maybe some examples would help. If I removed products from a reaction, this would disrupt the equilibrium, so more products would have to be reduced again to regain equilibrium. Also, if I added heat, the reaction would be exothermic, so more reactants would be needed.
Because exothermic equations have heat on the product side, while endothermic equations have heat on the reactant side.
Good job! Can you guess what will happen if I increase the number of reactants in the equation?
More products will be produced to match the number of reactants?
Yes, well it's going to get a little complicated now. Let's talk about rate law.
Oh, I know the equation for that.
Yes, that is correct.
Wait, what's that?
Well, K is the specific rate constant. So however fast the rate of determining factor is.
What's that?
The rate determining factor is the slowest step of a chemical reaction that determines how long the reaction will take.
The factor that determines the rate is the amount of time it takes for each person to get ready.
Come on now, let's go. Hold on. I'm brushing my hair.
Okay, we can go now.
Okay, continuing. A and B are the molar concentrations of reactants. Variables N and M represent order in each reactant, or the power or the exponent.
Oh, okay. Thanks, Dad. You're the best. I understand everything now, and I hope I get an A on my test.
Sabria and Nu take their chemistry test on reaction rates. Miss Bouquet collects them.
Okay, time's up.
I think I did pretty well. Me too.
While grading the tests, Sabria gets an F and Nu gets an C+,
Good job.
passing high school.
Yay!
Where's my test?
Oh, I accidentally threw it away and you can't retake it. Sorry.
Sabria is forced to drop out of high school.